A server action and a route handler can both create the same post, but they are not interchangeable entry points. The choice becomes easy when you stop asking which API is newer and ask one concrete question: who is calling this code? Today we will build both surfaces, put the same domain function behind them, and name the trade each adapter buys. Our architecture has two lanes. The internal lane is our own React interface, a form submission, button press, or optimistic mutation controlled by the application. The external lane is anything that speaks HTTP without our component tree: a mobile client, command line tool, partner platform, schedule job, or webhook provider. Both lanes may want the same business outcome. Only one of them can use a framework-bound function reference. The external lane needs an addressable protocol contract. For the internal mutation, use a server action. Mark the module with Use Server. Accept the form data or typed input. Parse it with the same schema your domain expects. Resolve the current actor from the server session. Check that actor's permission before the write. Then call Create Post Core and revalidate the page that displays the result. The UI gets a direct mutation path with framework-managed invocation and cache integration. But do not mistake convenience for trust. A server action is still a security-sensitive entry point and must authenticate, authorize, and validate every call. Make that action's return value intentional too. Expected validation failures should come back as a small typed result the form can render beside the field, not as an unhandled exception that turns the whole mutation into a generic error. Unexpected failures should be logged with a request or trace identifier and shown to the user without database details. If the form can be submitted twice, decide whether the domain operation is naturally idempotent or whether the UI needs a submission key. Revalidation should target the smallest path or tag that became stale. The action is convenient because the framework connects these pieces. It is maintainable because each piece still has a named contract. For the external caller, expose a route handler. Post/API/posts. Parse the request body. Authenticate the caller from the contract you support. Authorize the same create post capability. Validate the payload. Then call the same core and translate its result into HTTP, perhaps 201 with a JSON body, 400 for malformed input, 401 when no identity is present, 403 when the actor lacks authority, and a stable error shape clients can depend on. The extra work is the point. You are publishing a protocol boundary other software can address, observe, retry, and version. An HTTP surface also needs decisions the server action can keep private. What content types are accepted? Is the request body size limited before parsing? Is the resource identifier in the path or the payload? Will clients retry a timeout? And if they do, can post create two records? An idempotency key can turn those retries into one domain operation. Define a machine-readable error code separately from the human message so clients do not parse prose. Add cache headers only when the response really is cacheable. Version behavior through compatible additions first, because once another team ships against the route, changing a status code or field name is a migration, not a refactor. The adapters should converge immediately. Create Post Core receives a validated input and an actor. It enforces domain invariance, writes through the data layer, and returns a domain result. It knows nothing about forgery, React revalidation, request objects, or status codes. That separation keeps the rules testable and prevents two entry points from slowly becoming two products. It also makes the security review legible. Each adapter establishes a trustworthy actor and valid input. The core enforces the business rule. The database remains the final policy boundary. This seam gives you a practical test pyramid. Unit test the domain function with actors and validated inputs. An author may create a draft. A suspended account may not. A title must satisfy the invariant, and the write occurs inside the transaction the rule requires. Adapter tests then stay narrow. The action test proves session resolution, schema errors, and revalidation. The route handler test proves authentication headers, JSON parsing, status mapping, and idempotency behavior. You do not need to run every business scenario through both entry points because the core already owns those scenarios. That is the payoff of convergence. More confidence with less duplicate test setup. Now the easy-to-miss exception. A server component that needs posts should usually call the data layer directly. Do not make the component call your own route handler just to come back into the same process. That adds an HTTP hop, serialization, another error surface, and build time failure modes without creating a real boundary. And do not use a server action as a general data fetching API either. Actions are designed around mutations and their calls are queued. The rule is, not everything goes through one surface. The rule is, every real boundary gets the right adapter. Direct does not mean unstructured. Put the query behind a server-only data function, such as list posts for actor. That function can enforce the read policy, select only the fields the component needs, and participate in the framework's caching model. The component receives domain shape data without learning database details. If a future mobile client needs the same information, the route handler can call that data function and publish a serialized representation. You have reused the rule without forcing today's in-process caller through tomorrow's network contract. This keeps latency low now and preserves an adapter seam when a real boundary appears. Treat both entry points as public in the security sense. Never assume a server action is safe because the button is hidden. Never assume a route handler is safe because an upstream service normally calls it. Authenticate the caller, authorize the action against the resource, validate the shape and size of input, rate limit where abuse matters, and keep errors from leaking internals. If you use row-level security, preserve it as defense in depth rather than as an excuse to skip application checks. Different adapter, same standard of proof. The threats differ even though the proof standard does not. A browser mutation may need cross-site request forgery protection and origin checks because cookies attach automatically. A public route may need rate limits, token audience checks, and body limits before expensive parsing. A webhook route needs a signature over the raw body, timestamp tolerance, replay protection, and a fast acknowledgement before asynchronous work begins. Capture the actor type and credential provenance in structured logs, but never log the credential itself. When an incident arrives, you should be able to answer which adapter admitted the request, which policy authorized it, and which domain operation changed state. Here is the decision matrix. A server action buys excellent mutation ergonomics inside the framework, co-located server code, progressive form support, and direct revalidation. The cost is that it is not a general-purpose HTTP contract for outside callers. A route handler buys an explicit method, URL, headers, status, and response body that any HTTP client can use. The cost is protocol design, compatibility, validation, documentation, and observability you now own. Neither is more serious. Each is optimized for a different caller relationship. So follow the caller. Your own front-end mutation enters through a server action. An external HTTP caller enters through a route handler. Both authenticate, authorize, and validate, then delegate to the same domain function. A server component read skips both adapters and calls the data layer. When you draw those lanes, the architecture stops being a false binary and becomes a small set of purposeful seams. The route handler is now an intentional contract, which means we can give it its hardest caller, a webhook provider that retries, duplicates, arrives out of order, and expects a fast acknowledgement. Next episode, we build the receiver that survives all four.